Hello, and welcome to the presentation of the paper entitled An Appraisal and Classification of the Transdisciplinarity of Existing Design Tools. In today's talk, I'll contextualise the work with respect to the landscape of transdisciplinary engineering to arrive at the research aim. I'll then present the methodology followed in undertaking the research before presenting and discussing the key results, their implications, and direction for future work. To contextualise the research carried out, it is first necessary to define transdisciplinarity. This we take from Jansch, who describes this as permitting a project to work simultaneously on purposive, normative, pragmatic, and empirical levels, with multi-level coordination of the entire system towards a common goal. In the context of engineering, TD research has received less attention than in other disciplines, and due to this, working in this manner is not widely considered in engineering projects in spite of the benefits it brings. We propose that this can be enabled in part by the design tools and methods used, as they facilitate both collaboration and knowledge sharing in generating engineering solutions. As the level of disciplinary working enabled by design tools is at present unknown, the aim of the research is to appraise the level of disciplinary working afforded by a wide variety of design tools to enable the elucidation of tools that enable or inhibit working in this manner. In developing this understanding, it allows us to increase transdisciplinary working in projects by prescribing the use of tools that can enable it. In doing this, the research contributions are threefold. First, through presenting a method of assessing the transdisciplinarity of existing design tools. Second, through appraising a wide variety of existing design tools and approaches with respect to their ability to enable transdisciplinary engineering. And third, building upon the analysis carried out, we present the concept of transdisciplinary tool chains. In providing these contributions, we enable a move towards the explicit incorporation of transdisciplinary practices in engineering projects where they are at present rarely considered. To appraise the transdisciplinarity of design tools, a method of assessment was devised. This consisted of two elements, the assessment of transdisciplinarity and then a separate contextualization of the tool within the design process and association with its activities. Assessing transdisciplinarity involved determining if design rationale could be influenced and or conveyed at each level of disciplinarity. Separately, it considered if this was driven by the user or by the tool. And finally, whether the tool explicitly made links between different levels of disciplinarity. To contextualize the tool within the design process, this involved two further elements. First, whether a tool permitted the undertaking of design thinking activities, which are empathize, define, ideate, prototype, and test. And secondly, where in Palambyte's prescriptive design process the tool could be used. And the phases of Palambytes are task clarification, concept design, embodiment design, and detail design. In considering both levels of disciplinarity and design processes and activities, it is possible to determine if rationale at all of Jansch's levels of disciplinarity is linked through all phases and stages of design. The instantiation of this method presented in the paper was carried out by a postdoctoral research associate. It consisted of a time-variable assessment dependent upon familiarity with the tool. The list of tools assessed were from the University of Cambridge's Institute for Manufacturing, and the full results were compiled in a table and are presented in the paper. Key findings from the study undertaken are as follows. First, none of the design tools assessed were found to be transdisciplinary. This is due to them being unable to both influence and convey rationale at all levels of Jansch, whilst enabling links between these levels. This is very interesting, as it perhaps reflects a lack of value for this type of working in traditional engineering projects. Second, the majority of tools are user-dependent with respect to their disciplinary enablement. This means that the tool doesn't force design to occur at these levels of disciplinarity, and this is an important distinction which will be revisited later on. By making explicit links between disciplinary levels, the 6 tools shown in the table below can be considered enablers of transdisciplinary working. They are considered to be interdisciplinary, as they link distinct levels of Jansch and are generally shown to be more available in earlier phases of design. Given no tools were shown to be individually transdisciplinary, we considered the application of TD toolchains to enable this. To scope the requirements of such a toolchain to be TE applicable, we defined it as being able to both convey and influence design rationale at every level of janch, be motivated by the tool itself and not the user, and to make explicit links between levels. Development of this chain from the analysis carried out involves ensuring that all levels of disciplinarity are influenced and conveyed, motivated by the tool and explicitly linked, whilst also occurring at all the phases of Pal and bytes. So you can see here, looking at this excerpt from the large table of how we can use the analysis to find this. And you're looking for ICs and Ts in essentially all of these columns, and also that it occurs at every phase of Pal and bytes. We can also mark this graphically with Jansch's levels of disciplinarity here on the x-axis and Pal and bytes engineering design process here on the vertical axis, and we can map where these different tools are able to influence and convey rationale through the design process. So the tools included in the design chain are as follows. Products on a page allows us to clarify the purpose of the product and how it will achieve it. Belbin's team roles is included in order to clarify who is necessary to undertake the project and what their roles will be. Process on a page allows us to clarify the design process that will be followed. Quality function deployment, listed here as QFD, permits the linking of requirements to technical characteristics. Value engineering allows us to compare costs of different manners of delivering elements of a product's function. And FMEA, failure modes and effects analysis, allows us to identify potential problems in the product or design process, and it covers issues associated with organisation, strategy, product design, production processes, and individual components. The use of these tools in this order can, in theory, enable connections between all levels of janch throughout the full Pal and bytes prescriptive design process. One notable omission here is that it doesn't consider knowledge transfer between tools, which will be considered as further work. This final slide will conclude the research that's been presented. Assessing the transdisciplinarity of design tools is an important first step in assessing how their use can enable more effective transdisciplinary working in engineering projects. From the study carried out, we can make a number of recommendations and highlight steps for further work. An important conclusion is that none of the design tools assessed are transdisciplinary, and this shows that perhaps traditional engineering thinking isn't set up to be transdisciplinary, and this is evident in the design tools themselves. Encouraging TD working is an uphill struggle, in part because engineering design tools discourage this style of thinking and working. Building from this, a key recommendation is that transdisciplinary engineering education is crucial, as the majority of the tools assessed enabled working at certain levels of disciplinarity, but only if the user is able to use the tool in this manner. Transdisciplinary people are therefore essential in enabling transdisciplinary working, as the tools themselves can't be depended upon alone. This can be carried out through teaching students a wide range of TE skills, so they learn to be able to approach problems in this manner. In addition to that, further training is required to ensure that the tools are applied correctly in order to effectively enable TE working. With respect to further work, the following next steps will be undertaken. First, the development and delivery of TE workshops that can be used to teach TD principles such that they can be directly applied to students' research projects. Second stream of further work is to use the initial findings from the study and apply them to industry. The aim of this is to explore the way in which tools and tool chains are used in industrial processes to identify whether these can be considered transdisciplinary. Third, we will look into exploring knowledge transfer techniques so we can try enabling the transfer of design rationale across design tools. And if I'm going to very quickly summarize my summary, the key point here I would like to make is that none of the design tools were TD, and that if you want engineers to work in this manner, education is crucial and is very important. So thanks very much for watching. I'm happy to answer any questions in the live Q&A, or also feel free to contact me via email, which is shown on the slide in front of you.